Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. This video will be part 7 of my SolidWorks portable mist spray fan project. Alright, in this video I would like to show you another component of this portable fan. So this, as you can see from this photo, we have this unit. So this unit is for battery compartment. So we have a AA battery size rechargeable battery fit into this casing, like a compartment for this rechargeable battery, and also we have this one is for mist maker. So this is a mist maker unit. So it's a one thing, it's a one plastic casing here. So I will show you how we will do this unit for the battery compartment and also the mist maker. So mist maker, actually bottom here we have a straw. This straw will be merged into the water tank and it will produce. We have a kind like a small disc. This is what we call, I don't know the words, it's kind like produce the mist, right? So it's connected to this PCB and also connected to the battery. So that this unit that produce mist maker unit, all right, for this portable fan. So I will show you how we will do this, okay? How we will hold on, how we will do the whole thing, this casing, the white color here. Then later in the next video about assembly, then only I will show how we will fit it into this casing of rear casing and front casing. Alright, okay, as usual you're in the part modeling mode. Make sure that the unit is in millimeter. Alright, if you look in the photo, I already done the, hold on, if I show you the rough dimension that I've already sketched. So we have this thing, a mist maker unit, also a battery compartment. So here is a rough sketch that I've done, all the measurement that I have already taken, the basic measurement. And if you look, it's kind like it is a plan view. So we have a cylinder of diameter 36. So it means that this will be this diameter 36. Hold on. Right, so this is actually a cylinder, and the cylinder have a cutout like this. So if you look in this sketch, so you have a cutout. You have a cutout here, straight line. If I go this, you have a cutout. Basically, it's a cutout of dimension is 12. So actually, this is a cylinder of 36, and the thickness of that the cylinder, the main bit of this is 11. So I will do this part first. So it means I will do this portion first, and then only I show you how we will do the extra part. We have an extruded cylinder and also the extruded cylinder at the bottom. Right, the first thing I will show how we will do this one. So based on the dimension is we have diameter 36 and cutout of 12. Alright, in the SolidWorks, okay, make sure unit is mmgs. So I will do this in top plane. Okay, in top plane, so I will start by a diameter of 36. Diameter of 36. And if you look this photo again, the sketch, diameter 36 and the thickness is 11. So then I will do extrude of 11. Okay, extrude of 11. Then I will create a cutout. Right, a cutout as shown in this image, a cutout of 12. So we have so here in the top view. Alright, to do that I may have to make a cutout of, I will create line here. I will create line like this, and make sure it's kind of horizontal, but there is not a line to the center here. So I can do it like this. Select the line and right click the middle point. So the middle point, I have to make it align, order my control key to make it vertical. So it means this middle point is aligned with center point, the center of this cylinder. So I will put the dimension is 12, right? The dimension is 12. So I will give 12 here. So this is 12. So I have a fully defined straight line there, and I will do a mirror. Make sure I create a center line first, and I will do mirror entities. The entities to mirror is this one, and mirror about is the center line. So I have this mirrored line here at the bottom. So I will do split. So the sketch already selected here, sketch 2, then I cut part. So I select the portion that I need to remove. Make sure that consume cut bodies is on. So I have this cut out, right? Alright, the next thing to do, if you look in this photo, we have here at the top here, we have a cut out. So I will do shell for about 1 millimeter here. So we have a cut out deep. So the cut out of this thing, I will do shell by thickness of 1 millimeter. So I will do shell, and I only make sure that the distance is 1, and I only select the top surface here, then I do shell. So we have a cutout, right? Alright, the next thing is that if you look in this sketching here, alright, I already done this area, okay, and then we have a protruding cylinder here. This is a top view. I already make a sketch. This is a diameter of 18. Alright, the diameter of 18 is kind of like tangent here. If you look in this photo, the features is for this one. We have this cylinder, right? Diameter is 18 and extruded. If you look on my sketch of the dimension, so this diameter 18 is kind of like tangent to the outer edge of the cylinder that I've just created, and the length is 21. From here to here is 21 from this surface, the top surface of the cylinder that I've just created. So what I will do here, so I will create a plane at this flat plane, and I will put a distance of 21, make sure it is above. Okay, this is a position where I will do the cylinder. Alright, here the plane one here, I will do a sketch. So here I will create a okay, one way is I can create a center line from this here to make sure it touch that quadrant, and I can create a circle, and this circle I select this circle and this dot, make sure it goes for coincidence, so it means tangent at that circular edge of that circle. Okay, the dimension of that circle, if you look here, the dimension is 18. Okay, the dimension is 18, and the diameter is 18. So this I will do extrude up to surface. Hold on. Okay, I will extrude, and I will use up to surface, and it will stop at the surface, right? It will stop at that surface. Then I click OK. So we have kind of like one, they are merged together, right? It's kind of like touch here the tangent. So this will be features for this. If you look in this photo, we have this thing. This is for the mist maker unit, for mist making unit, right? So this cylinder. Okay, the next thing to do, if you look at the bottom part of this mist making unit, we have this extruded cylinder here, right? Extruded cylinder. So this is the bottom part, and we have a cutout of thickness of 1.5 millimeter. So if you look at my sketch dimension, so I'm talking about is we already done the center cylinder, and I also do the extruded part of the mist maker unit. And here at the bottom you have this cylinder of diameter 31 and extruded 13. Okay, so what I will do here, so this is the bottom side, right? Okay, hold on, 31. So let me drag this. So this is the bottom side of this this part, right? So I will do extrude of 13, right? Extrude of 13. So I will go blind and extrude of 13. So I have this bottom cylinder, alright? So this is a bottom cylinder, and I need to show you again. And the bottom cylinder, we have a 1.5 thickness cutout, and here, okay, convert, and I will do convert entities. So I have the outline, then I will do offset 1.5, so already 1.5 here, so I go for inward, and I will do extrude cut. Here I am using contours, so I select the inner region, and it's up to surface, so it will stop. Okay, up to surface, I'm using up to surface, so the surface that I select will be this one. So I have a cutout there, right? Okay, let me save my file again. Okay, I have a cutout at the bottom here. All right, if you look in this photo, we have at the bottom part here again, and so we have another this one, this casing, this cylinder extruded to this bottom side. So I have to make this cylinder, right, extruded into up until it touch that inner surface. All right, that's, if you look on my sketch dimension, what I'm talking about is this cylinder. Okay, actually here I mentioned diameter is 15, but actually it's not 15. I will show you later. But the distance here from here, the level of I make this cylinder is 13 plus 35. It will be from this surface is 35. I mean 35 is from here. Total is 35. From this level is 35. Then what I will do here, as shown in, let me check again, from this level to here is 35. So I will create another plane. It means I will go for 35 unit, right? 35. So that would be the level of my bottom cylinder. So here I will create a sketch. Okay, about this thing. All right, if you see, the idea is that if you look at this photo, this cylinder, the top cylinder is on the left side, but the bottom cylinder is on the right side. So it means that in my SolidWorks, okay, this is my plane number 2. Okay, this is my plane number 2. So if I go to perpendicular view, so it means that my circle will be here. So I have a guideline already. So I will create a circle here, right? So this circle, this one, and this center point here, I will make it coincide. And but for this side, okay, I will make it tangent. Okay, hold on. I will select this circle and this edge. I make it tangent, so it will stop at that point. So it's already fully defined. It's not as dimension that I mentioned is 15. Actually, is not 15. All right. So this one I will extrude up until up to surface, and it will stop up until this surface. So everything I make it merge together is one body, alright? So it kind of like merging. So this will be the bottom cylinder. This bottom cylinder is for compartment for the battery. Later I will extrude at this to where we mount the rechargeable AA batteries, right? Alright, the next thing to do, if you look in this photo, right, so we have, hold on. Okay, if you look in this photo, this bottom cylinder that I've just created, I have features here I forgot to add in, before I extrude it now. So we have a rectangular section here. Alright, the rectangular section will be extruded up until the surface. Alright, so I will add that here. If you, this is a standard ISO view. So that rectangular section will be at this quadrant. Alright, so here I will do a sketch. So it means I will create a center line from this center of, let me make sure you can track the center pointer. So I will create up until this quadrant. So this will be my guideline, right? Okay, the size of the rectangle will be, okay, the size of that rectangle will be, I'm now in sketch mode, will be, I use the center rectangle, so it start here. The distance here is 5. So this is 5. Right, hold on. And the height is 3.5. Okay, this one is 3.5, so this one will be extruded up to surface and stop here. So this one will be at together with the previous cylinder. So I have these pictures. Okay, these pictures meant for, it's kind of like provide a space where we have a wire to pass through, because it's a compartment for the AA batteries. So we have a connection to the battery, we have a wire to pass through. So this kind of like provide a casing space for wire to pass through. So since later I show you, we will do a cut out from this top surface, right, where we will mount the AA batteries. Alright. Alright. Okay, now if you look in this photo at the top surface here, okay, this battery unit will be fitted into this compartment battery, the second cylinder that I've just created. So I have created a rectangular area, the pictures of rectangular for the cable to pass through. And this battery, the green color is the AA batteries. Okay, actually I've done the if you look here, I've done the modeling of the AA batteries. Okay, this AA batteries, the AA batteries, I base my model it based on the standard size AA batteries. The diameter is 14.5 and the length is 50.5. Alright, so actually this battery will be fitted into here. Since I have not yet created a cutout holes here, so what I will do here, so I will create sketch here. Okay, I have to make sure my display is show hidden line. So I have the outline of the bottom cylinder and also the rectangular section there. Okay, since the battery will be fitted here, the battery diameter is 14.5, right? So I will create a here, make sure it can track this. Okay, this center point, so this will be the size of the battery. So I have to create a holes of 14.5, right? 14.5. So that will be the size of the battery. So it means the holes I have to make a extruded cut of 14.5. All right, and also here, as you can see, we have a rectangular section. Hold on. Okay, so I have the outline of that rectangular section. So I will do an offset of 0. Hold on. I will do an offset of 0.5. Okay, 0.5 of this. So I will select this one. I will select this line also, and I will select this line also. Make sure that I'm not using selection or not. So I just the most basic way of offset. So I create offsetted outline of 0.5, and now I can simply drag it like this and drag it like that. So this will be, then I will do trim. Okay, I will do trim. Right, so this will be the region for me to do extruded cut. Okay, the distance of that extruded cut, let me go back to shaded mode. And extruded cut is 35 unit. Right, so I will do blind 35. The distance is 35, then I click OK. Hold on. So it will make a cutout here. Alright, if I show you, so this will be the compartment for the batteries to be fitted. Okay, so this is a battery compartment. If I show you the section view, as you can see, so we have this thing, right? So this way will fit the AA batteries, rechargeable batteries. Alright. Alright, the next move is about this cylinder. If you look this top cylinder, I have not made yet features for this top cylinder. Actually, this top cylinder is meant for mist making unit. If you look in this photo, so this is a top cylinder. Actually, here we have a cutout where we'll have, okay, this is, since this is a mist making unit, so at the top here we have a soft disc material, a silicone disc will be fitted onto this top cylinder. So it means that at this top cylinder I make a cutout for the silicone disc to be fitted on top here, and also we have actually here we have what we call, this thing will be mist making unit. We have kind of like a thin plate, a cylindrical plate. We have kind of like what we call it a diaphragm, a thin plate, and it's connected to the battery and also connected to the PCB. And since this mist making unit, we have a straw merged into the water container, and the absorption of that water will goes up, and this mist making unit will produce a mist. This is how they do it to make a mesh maker. All right. Okay. All right. To do if you look on the sketch here, so I have if you look on this sketch, okay, if you zoom in this one, actually we have a cutout here. So what I mean, we have a cutout kind of like maybe about 2 millimeter deep. I make a cutout, and also I do an offset of the offset is about 0.5, right? So, and cutout deep. So what I will do here, okay, I select this convert entity. So we have an outline. I will make an offset of 0.2. Okay, I make it 0.2 and very thin wall. It goes inside. Then I make a cutout. So I will do extruded cut, and I'm using contours. I select the inner part, so I make it through blinds. I will go for maybe 2 millimeter deep, or maybe it's even let me see, it's 2 millimeter. Okay, it's 2 millimeter deep, and I click OK. So we have a cutout, a thin wall with a cutout of 2 millimeter. Alright, so at this surface, what I will do, if you look in this sketch, so I have a kind like diameter 9 cylinder extruded. So it means, okay, at this one, I already in sketch mode. I go to perpendicular view, so I will create a circle, make sure it track at the center point, diameter 9. Okay, diameter 9. So not too much, it's about maybe 0.5 millimeter, 0.5 millimeter extrude, right? It's about 0.5 millimeter, so it goes up. Hold on, I'm using blind. Okay, then it goes up. So this is meant for the 0.5 millimeter. Maybe I can go to 1 millimeter. Let me change to 1 millimeter, a little bit higher. So this meant for the silicon disc to be fitted. Actually, silicon disc is together with the diaphragm unit, the thin plate, and it will be fitted onto this cutout, right? Okay. Also, we have a cut through holes here at this surface. If you look on my sketch here, I have a small circle will be cut through. That's meant for the straw to pass through. So we have a straw for the mesh making unit. So it means that here I will create at the center point of, if you look on my sketch, it is diameter 6, right? Diameter 6. Diameter 6, and this one will be extruded cut through all. Okay, this one I go for extruded cut through all. So we have a cut through all. This meant for the straw to pass through, but actually we have kind of a protruded cylinder here for the where we will mount the casing for the straw. So as shown in this sketch here, we have a casing. So this tube, what I mean is a tube. The tube will be put into here, right? Will be fitted into here, and we have a straw. Since straw is the standard material, I will not do modeling of the straw, right? And the straw will pass through. The straw will be fitted into this tube, and the tube will be fitted into at the bottom part. Alright, the next thing to do, if you look at this photo, so this is a bottom view. This is a bottom view. So I already make a cutout of, if you look at this photo, let me show you another photo of it, and this view, right? So I already make a cutout of 6 millimeter. If you look in here, so this will be, I make a cutout, since we have, so this is actually for mesh making unit, and actually if you look at this photo, we have features like a protruding cylinder, but before that I have to make a bigger cutout of this circle. So this circle I already measured it for diameter of 16, and I need to trace the outline of the circular edge. Alright, I will make an extruded cut. How deep it is? It will be around about 26 millimeter. It means kind goes up, so that extruded circle will be goes up until about some thickness here, right? So here, okay, at this surface I will create a sketch here. So I will do a circle at the center point. So the diameter of that circle is 16. Okay, it will be 16. All right, 16. Then I need to trace this one, convert entities. So I have the outline there. Then I will do trim. I just need this region, right? So I have the region. So this region I will do extruded cut. It goes above a cut until we have some level here. So I will do extruded cut. The distance is 26. Right, some value there. Maybe I can go for, let me check, go for 27. Okay, then I click OK. So you have a cutout. Okay, we have a cutout. Okay, cutout. So if I go for section view, as you can see, we have a cutout. Right. So this cutout is so we have some thickness. So let me adjust instead of, hold on, let me adjust for the extrude cut. I go for 28. Right, so 28 is the distance. Alright, so what I will do, then I will show this photo. We have, if you look at this photo, we have a protruded cylinder from the inside surface there. So it means here, I will create sketch. So this one I can convert entities, and I will do an offset. I think the offset thickness of this protruding cylinder is 1 millimeter. Offset of 1, select this one. Alright, and I click OK. So then I will do extrude and up to surface. So I will go up until the surface. So I have a protruded cylinder. Okay, I have a protruded cylinder. Alright, if you look in this photo, we have a features what we call this four thing, we call it rib. Right. Okay, actually the rib, the level of the rib is a little bit not on the same plane as this level. It's kind of like hold on, it's kind of like half of the some distance from the surface. Okay, what I will do, I will create a rib. The way for me to do create a rib, so I will put at the plane. So I will make a plane from this surface. It's not going up. I put some value of maybe 5 unit, but it go fully offset. So it's kind of like a distance, about some distance of around, I will go for 10 millimeter instead of 5. Okay, later I can adjust the value. So it will go for 10 millimeter. Okay, so this will be the level of the plane I will do rib. So this plane 3, I will create a sketch. So I will create a rib. Okay, in order for me to create a rib, so this is a protruding cylinder. So I will create a line at this quadrant, make sure that it goes like this. Quadrant, so this will be, since we have 4 ribs there, and from this quadrant to this quadrant, I have another line from this quadrant to that quadrant, and we have some balance here. This line from this, make sure that it snap at that quadrant and it touch this line, right? So I have these 4 lines for me to create a rib. So under features here, we have a rib. Okay, rib. Okay, the default value thickness of the rib is 10. If I go for 1, so we have a thickness of 1. Let me check again. I think the rib is about, I think it's about 0.5, not that thick as 1, 0.5 millimeter. And make sure that the pointing, if you can see here, we have an arrow pointing of where we want to project the rib. The projection is downward. If it is like this on the left, on the right, so this is not right, because I want to project the rib downward. So I go for the second option here. It goes downward. If I go flip material side, it goes upward. That is not right. So I uncheck the flip. So make sure the projection of the rib is downward. Then if I click OK, so as you can see now we have a rib. Okay, the rib is meant to strengthening this protruding tube, protruding cylinder. Okay, let me save my file and let me go for standard view. So this is a features for this making unit and also the battery compartment. All right. Okay, the next move, if you look at this photo, at the bottom cylinder here, we have features we call this internal thread, not an external thread. It's an internal cutout thread. Okay, the thread shape is not a V shape, it's a square thread, and the cross section is kind of a rectangle. So the rectangle is about 1.5 and 0.5. So the length 1.5, thickness is 0.5. So I already measured the length of the thread is about 10 millimeter. It's about 10 millimeter, and the number of revolution is N is 3. 3 is the number of revolution. So at the end of this video, I'll show you the last thing to do for this video. I show you how I will do this internal thread, right? Alright, okay, here in SolidWorks, so it means this thread will be at this surface. Okay, since I already know the diameter here is 31, so I would create, okay, in order for me to create the internal thread, I play around with helix. Okay, the helix level is start at somewhere not at the surface. I will put, so what I will do, I will create a surface from this surface. I make an extra about, I think about 2 millimeter. So it goes downward. So I made a little bit not on that surface. So this is a level where I will create a starting point for me to create a helix. Alright. I need to create an helix shape, okay, a spiral helix to create an internal thread. So this will be my plane number 5. So this plane number 5, I create a sketch. Okay, just go it like this. Alright. Okay, now I'm in sketch mode, so I can trace this circle, convert entity, so I have a trace outline. In order for me to create an helix, I need a base circle. So this is a base circle, the size of my thread, the diameter of my helix. Alright, okay, here when you have a trace circle here, if you go to features, hold on. Under the features here, under the curve, I'm still in sketch mode. If you click at the cursor, we have helix and spiral. Okay, I explain you the most basic way. If you look on the setting on the left, by default it goes for pitch and revolution, and it goes downward. I don't want my thread to helix to go downward. I need to go upward. So I will go for reverse direction. So it goes upward. But if you look, we have a preview of an helix. Instead of using pitch and revolution, I will go for height and revolution. Okay, the height of my helix, I need say, okay, since the distance, okay, let me cancel my helix. I need to know the distance, and let me exit. Okay, if you look here, the distance, if I check, evaluate, if I measure from this plane to the surface, it shows that the distance is 15 millimeter. Alright, 15 millimeter. Alright, so it means that, okay, let me active this sketch. Okay, I need to create an helix here up until the length of this cylinder. Right. Okay, now I have the base circle already, so I'm now in sketch mode under the features. So I will go for helix. So instead of downward, I go for here reverse direction, so it goes upward. I'm not using pitch and revolution, so I will go for height and revolution. So by height revolution, I can control the height. Okay, if I go for the height about 10 millimeter, so that will be the end of my thread, the end of my helix. I need to make it a little bit longer. I make it 13, so it goes, my helix or my internal thread will end up until that one position. So I go a little bit deeper, about 14 millimeter. Alright, I think I'm satisfied with 14. As I mentioned, the number of revolution is 3. Okay, if I go for 3, so this will be the number of revolution of my thread. Okay, I can go here. Okay, start angle. Okay, start angle, it means this is the line of the curve of my helix as shown in preview yellow color. So this will be my starting point, because by default is 45 degree. If I go for 0 degree, it means the starting point will be at this quadrant. So I make it at 0 degree, and if you look, let me check again. If I look at my actual product, the direction of my helix is either clockwise or counterclockwise. So this one is supposed to be clockwise, not counterclockwise. If counterclockwise, we go for reverse thread helix direction. So I go for clockwise, and the distance is already set 14, and I go for 3 number of revolutions. So if I click OK, so I have a 3D curve. Its helix is a 3D curve actually. Okay, now I can off this. Okay, so I have this helix Okay, I need to create a internal thread. For me to create internal thread, I can go command called sweep, swap boss base, but I need a cross section because I already have the path to create the sweep. I'm not using swap boss base, I'm using swap cut for me to create the internal thread. Alright, I already have the endpoint, so what I will create, I will put a cross section at this endpoint. I need to put a plane here. So I will do plane, so I will select at this curve is my first reference, this helix, and the second reference will be at the end of that point of the helix. So I have a plane which is perpendicular or normal to the. Alright, if I look exactly, if I go for like this view, if you look on the plane 6, is kind of like not vertical. If I'm not satisfied with this, I can delete this plane. Right, I don't want it to be, I want it to be straight vertical, so it means that I'm not using the way that I just show you. So I'm using plane again. Okay, the first reference will be I will use right plane, and the second reference will be this dot, so it means my right plane is really laying at that position, so it's much better compared with the plane that I just created. So I'm using this plane 7, which the right plane. The idea is for me, my cross section is kind of like vertical to the right plane, it's in line with the right plane. So this plane 7, I will create a sketch. So as mentioned to you, I will create a rectangle. The rectangle that I will create, I will go for corner rectangle, start from at this endpoint. Okay, if not snap at that point, I just simply create a rectangle like this. As I mentioned to you, the size of that square thread is 1.5. Okay, 1.5 is the length, and the it's not updating, and here is 0.5. Okay, 0.5 is the thickness. Hold on. So this would be the, hold on, it's not updating. Alright, the idea of me creating this profile, if I will use swap cut, I have a profile, and this one will be the path, right? So this will be the cross section, this will be the path, then I will do swap cut to create the internal thread. But I need to position this profile onto this helix. So this is a helix that I have just created. Alright, if I bring here, I cannot, here, if I select this midpoint, right click at it at midpoint, if I cannot select the endpoint of my helix. Alright, one way is to do that is I will hold down my control key and select at, not at the endpoint of the helix, somewhere at the curve of the helix here. So we have option make pierce. But I found out when I do make pierce, when I do, I just need to show you when I do. Okay, here I already have the profile, right? Okay, let me off this. The curve, that the circle. So I have this profile. If I do swap cut, I have a cross section, and the path is this helix. When I make a swap cut, so it kind of like produce errors because it would result in zero thickness geometry. Okay, in order to overcome this problem, okay, let me undo the position. I undo back until my cross section is like this. Alright, okay, let me off this circle. Right, I cannot put the midpoint here to here. What I need to do, I need to create a point first. I create a point, and this point, and I select at the end of this helix, I make to make pierce. So it means I have a reference point there. So this will be at that endpoint of that helix. So what I will do here, I will bring this, I can scroll down this cross section. I will do it like this. As long I don't want my middle point of this to be really in at this point, I put some small amount, maybe 0.01 distance, because so that when I do swap cut, it will not produce zero thickness. So I have to put some amount here. So I will put a dimension from this point to here. I put it around 0.01, very small distance. Okay, then I have already put the position like that. So one more thing is that I need to make sure that this rectangular section is in the middle. So I will select this middle point and this point. I make it, hold on, okay, I select this one, select the midpoint of it, and I hold down my control key, select this point, I make the relation horizontal. So now my cross section is fully defined. Okay, now the idea of me make a tiny distance here, 0.01, so it means that when I do sweep cut, it will not produce zero thickness. So I already have this profile. Right, so what I will do, features when I do sweep cut, so this one will be the cross section. I select the rectangular section, and the path will be the helix. When I do sweep cut, okay, now my sweep cut is successfully done. So we have an internal thread there. So one more thing is I need to check here. My helix I already adjusted the distance. I can control how much, how far the helix I want to go up. It depends on the helix that I've just created. I make it 13 from here. All right. Okay, I have created this internal thread. Okay, when you look at it, if I view at this position, it kind of like the thread is kind of like too close to this surface here. Because if you look in this photo, we have, if you look, right, let me, all right, here, this is the helix, the internal thread I have already created. I need some distance here. I need to increase the distance here because here we have cutting a slot, since I already removed this silicone sealant or rubber sealant. So the silicone sealant or rubber sealant is fitted into the slot, so it meant to prevent water leakage. Alright, I need to give some further distance. It means that I have to increase the gap here. So here in the helix distance, I adjust it. So the helix distance of 13, so I make it around 12. So I need some gap there. If I put it 12, so I have some space for me to create a cutout. Right, create a cutout. So let me adjust the height of the helix. I put it around 11. I still have 3 revolution. Alright, this one I think is okay. So I have some space for me to create the slot here. Right. Right. If you look in this photo, I'll show you again. This photo we have a slot here. Okay, we have a slot. So this is a slot. The profile of it, I will do revolve cut. So the profile is 1 millimeter, and the depth of the cutting slot is 0.5. Right. Alright, so here in SolidWorks, if I go for standard view, okay, I will go, let me off this helix. I need this helix, I can off it. Right. Okay, let me save my file, and if I want to do a revolve cut to create a slot, so I will go on the front plane. Okay, I'm now in sketch mode, so I will create a revolution axis, this center line. So okay, similar approach, I cannot, if I put my rectangular section like this, I want to make cut out like this, it kind of like when I do revolve cut, it will produce zero thickness. Okay, one way to do that is I delete the relation. It's not to be coincident. I put it some value there, so I have some, it means that it kind of like little bit on this side, I need to put some very tiny distance. I mean from this line to this line. Sometimes not snapping, or the horizontal dimension from this line to sometimes you cannot. Okay, sometimes because it's depend on the resolution of the screen. So I need to put it tiny distance 0.1. You need to be a little bit upward. Because I try to avoid when I do revolve cut, it will do zero thickness. I put it 0.1 since I want the depth to be 0.5, so it means this length is 0.6, right? I want the cutout to be 0.5, so it means right. So I already have this thing, and this one is 1, right? This one is 1. And okay, actually it's not snapping to this. I need to make it kind of like snap here. So I have a fully defined. Okay, now I can do revolve cut. Okay, features here when I do revolve cut. Okay, full revolution, then I click OK. Okay, I adjust the distance is 0.05. Sometimes it produce error, you will produce zero thickness. If I go for 0.1 here, and I put it, since the dip is 0.5, so it means I added 0.6. If I go for 0.1, so the idea of me doing this, because when I do revolve cut, sometimes SolidWorks cannot calculate, it will produce zero thickness. So I kind of like put some small amount distance here to this side. To avoid zero thickness. Okay, if I go for 0.1, if I exit the sketch, when I do revolve cut, if I select this profile, okay, and it's already detected the axis of revolution, it will produce zero thickness. So let me cancel again, and I did this sketch, and if I go for 0. Really tiny gap here, sometimes you have to do it like this. So it means, okay, this is okay. I remain is as this one. I put it at 0.5 because I make a small amount, 0.5 the dip. Okay, if I exit the sketch, and when I do revolve cut, okay, alhamdulillah, you can create the slot, right? So this is a slot for me, meant for this. If you look at this photo, this meant for the rubber cylinder to be fitted onto the slot, right? Onto the slot. So let me save my file. Okay, let me go for standard isometric view, and okay, I end this video up until this position. So I think I've done this component, which is the mist maker and also the battery compartment. Alright, later in the next video I will do more detailing on the other components. Inshallah, I will see you in the next video. But before that, please do not forget to click like and subscribe my channel. Assalamualaikum warahmatullahi wabarakatuh.